Hey everyone, welcome back. Let's quickly recap what we learned yesterday. So consider an exponential function written in the form f of x equals a times b to the x power. Which key feature of the exponential function does the a term represent? The a term is the very first number. Is it the x-intercept, the y-intercept, or the common ratio? Y-intercept is correct. The number in place of A is the point where your exponential function graph crosses the y-axis. Let's figure out which key feature of the exponential function the b term represents. Is it the x-intercept, the y-intercept, or the common ratio? B is raised to the power of x. Common ratio is correct. Moving on today, our goal is to be able to take this algebraic equation and sketch the graph of the exponential equation. The very first step that we are going to do is going to be able to create a table of values using the formula y equals a times b to the power of x. If we start off by identifying the value of a and the value of b, we know that the value of a must be 1 because 1 times 2 is 2. So 2 to the power of x. A is 1 and b is 2. Very important to identify a and b. When you create your table of values, you can make a very simple t-chart, your x and your y values. And when you're selecting your x values, it's always important to include the origin, 0, 0, and to include 2 points less than 0 and 2 points greater than 0. And that'll give you a nice sized graph. Now you can do this by creating your own t-chart on your paper and substituting and evaluating. Or don't forget, you can go to Desmos online graphing calculator and type in this equation and pull up your table that way. So to create your table of values, remember I said go ahead and pick two values less than 0, so -2 and -1. Those are just random points. You could honestly pick any that you want, and you are going to substitute -2 into x right up here. So if I did 1 times 2 to the -2 power, 1 times 2 is 2. So I have 2 to the -2 power. Anytime you have a negative exponent, it's very important. We cannot leave that exponent negative. We have to take the inverse and make it positive. So that means you are going to flip that. So that would be 1 over 2 to the +2 exponent. And 2 squared is 4. So when x is -2, y is 1/4. We're going to continue that substituting. So I'm going to take another random value for x. So I'm going to say -1. I'm going to substitute that in. So x is going to become -1. So I have 2 to the -1 power. To make that -1 positive, I have to make it a fraction. So rather than having 2 to the -1 power, I'm going to have 1 over +2. Continuing that table of values, when x is 0, remember anything raised to the 0 power is 1. And when x is 1, anything raised to the power of 1 is itself. So 2 to the first power is 2, and 1 times 2 is 2. If x is 2, and I substitute 2 in for x, 2 to the second power is 2 times 2, which is 4, and 4 times 1 is 4. When x is 3, that's the same thing as saying 2 cubed. So 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 1 times 8 is 8. Another way that you can look at this is to say that I know that my y-intercept occurs when x is 0, and that is my a term. So I know that when x is 0, y is 1 for this particular exponential function. I also know that this 2 right here, the times 2, means that that is what's my common ratio. So I could take 1/4 times 2, and that gives me 1/2. 1/2 times 2 gives me 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So you can either substitute and evaluate, or you can look for that pattern and extend it. Once you have your table of values, you are going to plot each ordered pair over in your coordinate plane, and it will look something like this. And now you have successfully graphed that exponential equation. If we continue on a little bit and we now need to describe that exponential equation, let's talk. Is the graph increasing or is it decreasing? Remember, we read a graph just like we read a book, and we start on the left and we move to the right. So as I approach this graph, as x is increasing, and I'm going from -4 to 0 to when x is 2 to when x is 4, as my x values are increasing, my y values are also increasing. So we would describe this graph as increasing from left to right. Something new that we will talk about as we look at exponential functions, we will talk about the end behavior of the graph. And so I want to explain to you what that means. As x increases, and we just looked at that, so as I move from left to right along my x-axis, what is happening to the y values? Are they increasing? Are they decreasing? Are they going up? Are they going down? So as x increases, let's just take example, when x is 0, y is 1. When x increases to 2, y is 4. So y is also increasing. So we can describe that. So the end behavior, as x increases, y is also increasing. But let's look at it as x decreases. So as x gets smaller, this arrow here, part of an arrow, this arrow here means that that graph is continuous. It's going to keep on going. But x could get smaller and smaller. So when x is 0, y is 1. When x is -2, y is going to be a fraction. And it's going to get really, really, really close to this x-axis. So much so that it almost looks like it's touching it. But it's in actuality, it's not going to touch it. It is going to do what we call approach 0. It's going to be super duper close to that x-axis, but it's not actually going to touch it. It's going to approach 0. And that's the end behavior of the graph. So we're looking for the arrows on either end. And we're going to describe it as, is it increasing or decreasing, the y values, or are they approaching 0? If we look at example 2, consider the exponential equation y equals 1/2 times the power of x. The very first thing you want to do is identify your a value and your b value, and then you are either going to do substitution and evaluation. You can use Desmos online graphing calculator to do this, or you can make your own table of values, your x and y t-chart. These values for x, while you can pick anything, these values are pretty standard. So you can always start by making x is -2, -1, 0, 1, and 2. Those 5 points will give you enough so that you can describe the behavior of the graph. When x is -2, okay, you are going to go ahead and substitute that in. So you would have 1/2 to the -2 power. Remember, no exponent can stay negative. So what we would do is we would rewrite that with a positive exponent. So that would be 2 to the second power, and 2 to the second power, or 2 squared, is 4. Now, you could do one of two things. You could say, okay, well, 1/2. I am dividing by 2 or multiplying this value by 1/2. So if I did 4 times 1/2, I'm getting 2. If I did 2 times 1/2 and I kept continuing this pattern, 2 times 1/2 is 1. 1 is the value of A, and it's also the y-intercept. 1 times 1/2 is 1/2. 1/2 cut in half is 1/4. You will take these ordered pairs here and you will plot them so that you are looking at an exponential equation. And this one looks a little bit different than the other one that we looked at. But we can still talk about this graph and we can describe it. So if we look at, is the graph increasing or decreasing? So remember, we read a graph from left to right. So if I start and I follow my x values, as x increases, what's happening to the y values? They are going down. This graph is going down. It's starting high and it's going down, so it is decreasing. When we talk about end behavior, and that's a new vocabulary expression for us, that's talking about the ends of the graph that we can see. So what's happening as you move towards the arrows on either end? As x is increasing right here, all right, as my x values get further from 0, as they are increasing and moving towards the right, the y values are actually getting smaller and smaller and smaller. They are approaching 0. Remember, they're going to approach that x-axis, but they're not actually going to touch it. As x decreases, as I move further to the left along the x-axis, my y values, when x is 0, y is 1. When x is -1, y is 2. When x is 2, y is 4. Those values are increasing. When you look at example 3, consider the exponential equation y equals -2 to the x power. We want to identify our a value and our b value from this equation. We want to make a table of values or use our Desmos online graphing calculator to get our ordered pairs, and then we want to plot them over here. So the a value is -1. The b value is +2. -1 times 2 gives us that -2. Written that out. I've made my table of values, okay, keeping the standard -2, -1, 0, 1, and 2. I can look at this and I can say very quickly, I know the a value is my y-intercept. So when x is 0, y is -1. I can then say, okay, well, I'm going to multiply by my common ratio. So I'm going to go -1 times 2 is -2. -2 times 2 is -4. And I can work backwards the exact same way. And my graph is now going to look something like this. Is the graph increasing or decreasing? Remember, read your graph from left to right. So when you hit your graph, as x increases, right? As x goes to 2, y is -4. As it goes, x is 4, y is -8. So this graph is actually decreasing because as my x values are increasing, my y values are getting smaller. If I'm describing the end behavior of the graph, that's where I'm looking for my arrows. So as x increases, y is decreasing. We just looked at that. As x decreases, so as x becomes -2 and -3 and keeps on going, my y values are approaching 0. take a minute and click through this conclusion table to summarize what we've learned so far in this lesson today about graphing exponential equations. Please be sure to take notes on this. End behavior is a new term for us today.